Hello everyone, we are doing a bubbler system today. So we are looking at the level of the tank. So here's our tank right up here. And we have a tube running down inside that comes down to this level right here. We're going to be zooming in closer, but I need you to see the whole picture. So we have the tube that comes down to here, and it's open-ended tube. And the tube comes up and comes over here to this is our constant differential pressure relay. It is teed into our Rosemount differential pressure cell. It doesn't need to be a differential pressure cell. It could be a straight pressure cell, but we have a differential. And the constant differential pressure relay is supplied air from a regulator here. Now, what is the air supply that is needed? Well, the constant differential pressure supplies 1 psi greater than whatever is required to overcome the level of the tank. Now, when we apply 5 psi or 6 psi, we're applying 6 psi. That means that if the level of the tank is 0, that means that the constant differential pressure relay will output 0 pressure plus 1 psi. So right now, 1 psi pressure would be being pushed out of that constant differential pressure relay. But because it is only a small amount, small volume of air, the actual pressure that is sensed in this line, because it is flowing out of that open-ended tube into the transmitter, is going to be 0, even though this applies 1 psi greater. The reason why it's 0 is because it applies 1 psi greater at a flow rate of 2 cubic feet per minute. So a very small volume of air. If it was a higher volume of air, then you would get back pressure and your readings would not be correct. So let's start this up. We have in our control, in our electrical loop, we have our transmitter, which we have powered on. We have a MC1200, and that is our process calibrator, and we have a part communicator. Now, we're just going to turn that on. So what we're going to do is we're going to zoom in. We are using a variable frequency drive to bring the water into the tank. We're going to close the tank outlet valves, and we're going to zoom in. Now, what we can see, I'm just going to bring a chair over here. What we can see is we have 0 level in the tank. I know that's hard to see right now, but there's 0 level in the tank. Okay, we are right here. Now, the one thing is we are actually lower than the opening of our tube. We cannot tell the level below the opening of our tube. We can only go as far as the bottom of our tube. Our tube sits about 2 inches off the bottom of the tank. So immediately we have to fill up our tank about 2 inches before we can get our 0 point, which would be 4 milliamps. Right now we're at 3.9. Okay, we went a little bit high there. And we're at 6 milliamps. So I'm just going to let a little bit of that water out until we come back down to our 0 point. Okay, so now we have reached our 0 point, and we're actually reading 4 milliamps. That is 3.996 milliamps. So that's pretty well 4, and that is right here. Let me just lower that down a little bit here. Here we go. We are right here. I know that's very difficult to see. I apologize. Okay, so if we wanted to see what the differential pressure cell was reading, we would go to our heart communicator and we would look at our process variable. So we're just waiting for it to read here. Okay, proceed, and we are going to look at our process variable. The PV says that it is reading 0.8 inches of water, and that is our 0 point, okay? The reason why that is reading 0.8 is because it is a little bit higher than the bottom of the tube here, okay? So it is literally 0.8 inches above the bottom of the tube, and that's why we are receiving 0.8 inches. Now, if I look to see what my span was, I could simply go to my process variable, or to my go back out, proceed, and I could go to configure, and I can look at what my change outputs. So I'm in units, inches of H2O. I know that's very hard to see, but I will read it out to you. And I can go to my 4 milliamps is 0.85, and my 20 milliamps, so my 0 is 0.85 inches above, not the bottom of the tank, above the bottom of the tube of the bubbler. My span is 28 inches. So right now I'm almost at 2 inches. So when I get up to 30 inches, so from a little over 2 inches to almost 30 inches, that's my 0 and my span. So now I'm going to go back to my process variable so I can read it out to you as we move up. So I'm going to start my pump, and I'm going to go up to 50%. 50% should be 16 inches. And just looking at the 25%, we have, well, we're a little over 8 milliamps, and it would have been 16, 8, 9. It should have been around 11. So let's go up to the 16 mark. So we're just past 16. I could go over and do the valve, but we're close enough. It's just above 16, and we have 12 milliamps, and we are reading 15.4 inches of water, of H2O, pressure. And that's exactly what we expect to see, because you have to subtract the 2 from the 30, which gives you 28. So 50% of 28 would be 14. Add 2, that's 16, and we're just above 16. So now we'll go up to 30, and we will get our 100%. Uh, 29 actually, sorry. So we got to go a little bit higher. Or sorry, we're supposed to go up to 30 inches. Right there, 30 inches. So at 30 inches, we're just a hair above, and we have 20 milliamps, and we are reading 29.2 inches of water, which is perfect. That is the bubbler system. Thanks for watching.